Hey folks, how's it going? Mr. Murray here, coming to you with a video on translations in the coordinate plane. So in this video, what we'll be doing is we will be talking about how to translate shapes, though it could be applied to points or lines, but we'll be mostly focusing on shapes, and we'll be talking about how to execute them both geometrically and algebraically. So let's start with a little definition of what is a translation. So as you can see here, a translation of a point, line, or shape in the coordinate plane is the movement of that point, line, or shape left, right, up, or down. They're commonly also referred to as shifts, and essentially, as you can see here, we're just moving the shape around, again, left, right, up, or down, and we can actually do a combination. So if you look at this trapezoid here, starting at the pre-image, which is what we have before any translation occurs, to the image, which is the final form after that translation occurs, we've moved both up and left. Now, a translation, as you can see here, is considered that is a rigid motion, and that's because when the shape is moved, the distance between any 2 points, either on or within the shape, remains the same both before and after that translation occurs. Okay, so as you see, the distance, for example, between C and D is 4 before and after we do the translation. Okay, and that is what you call a rigid motion. The fact that it's a rigid motion is actually very important, and we'll see what the significance of the rigid motion is as we go forward when we talk about things like the congruence of shapes. So again, in this video, we're going to be taking a look at how translations work, what translations are, and a variety of ways to represent those translations. So some things worth discussing, again, some vocabulary. So again, the pre-image is what you call the shape before the translation or any transformation for that matter occurs, and the image is what happens after the transformation, in this case translation, has occurred. So as you can see here, we have the image, the pre-image of A, B, C, D, and in this case it is translated both up and left to create the trapezoid A prime, B prime, C prime, and D prime. And so this little tick mark almost at the end, we call that prime. And that is used to differentiate between the shape before the translation or transformation has occurred. It doesn't only have to be a translation, as we'll see, and the final result. Okay, so we can see that when it does not have the prime on it, that is before pre-image. When it does have the prime, that is after the image. Now, there are 3 different ways that we can describe a translation, and they all have the same meaning. They're just different ways of referring to the same idea. So we have a verbal representation, and this does not have anything to do with the picture that you see here. It's just an example. So we could say A, B, C, D is translated up by 3 and left by 6. So we're verbally describing what's happening. We could use a vector and say A, B, C, D is translated according to the vector -6, 3, and these pointy brackets here are not referring to less than or greater than, though sometimes they're used in inequalities. It's just a more compact way of saying left by 6 and up by 3. You can see how there's like an X and a Y, kind of like a point. And then finally, we can use coordinate notation where we translate A, B, C, D according to the rule, and we use X, Y as if it's a coordinate point going to. So this is kind of almost like an arrow. Unfortunately, it's kind of hard to make an arrow using the text boxes in Smart Notebooks. So you could also use the arrow, and then X minus 6, Y plus 3. So this is describing what you are algebraically going to be doing to the points to get from the pre-image to the image, okay? And so the vector is actually very unique to this specific type of transformation. And as we go into rotations and reflections, we may be using coordinate notations and things related to coordinates, but we will likely not be using vectors. Okay, vectors again are going to be exclusive to translations. All right, so to give you a sense of some examples, I'm going to start, and there will be eventually some problems for you to try out. We're going to start by translating along a vector, okay? And so this vector you can see here is -3, -4. So this means the same thing if we're going to do it in coordinate notation as taking our x's and our y's, and we're going to be subtracting 3 from the x's, and we're going to be subtracting 4 from the y's. Okay, and so a vector, another way of looking at a vector, if we were to kind of like visualize it, is it would look something like this. Okay, so we'd be translating along, and this has what we call a magnitude and a direction. So it has a sense of how much the thing is actually going to be moving, but it's also paired with a direction, specifically in this case, left and down. So let's take a look at what the new shape's going to look like. I'll do this one in blue. So the point E, we're going to move it left by 3 and down by 4. So it's going to come on down here. D is going to be moved left 1, 2, 3, down 1, 2, 3, 4. F is going to be moved down over 1, 2, 3, down 1, 2, 3, 4. And G is going to be moved over 1, 2, 3, down 1, 2, 3, 4. Okay? And so we're going to want to label these E prime, F prime, G prime, D prime. Okay? So in this case, and I'm just going to erase this just so I have a little bit more accuracy, and we probably want to redraw, if my Smart Notebook will cooperate with me, that vector. So we're going to be moving along this vector right here, and this is going to be creating our brand new shape. So we move what's called parallel to the vector, right? We're going to be moving every point. We could actually draw that vector over 3 down 4, and every point is going to move according to that vector. Okay? So then we get this new shape, DEFG. So again, the vector is just a compact way of describing precisely how things are moving. So if we were going to describe this verbally, we would say the shape DEFG is translated left by 3 and down by 4. Okay, let's take a look at another example. We're going to be translating according to the rule. So in this case, let's take a look. So we have 3 points here. We have A, which is 0, 1, not 0, 0. We have B, which is 5, 1. And we have C, which is 0, 4. So if we translate according to this rule, here's how we're going to determine our A prime, B prime, and C prime. So to get A prime, what this tells us is you take the x and you're going to add 2 to it. So x is equal to 0, so adding 2 to 0 is going to give us 2. And y is equal to 1, so subtracting 5 is going to give us -4. Here we have 5, so we are going to add 2, which is what our rule says to do. That brings us to 7. And we're going to subtract 1. So that's going to bring us to, subtract 5, that is. So it's going to bring us to -4. And for C, our rule says to add 2. So that's going to go from 0 to 2. And we're going to subtract 5. So we're going to go from 4 to -1. And now that we've applied the rule, we have 3 points that we can plot. So A prime will be moved to -4. Okay, B prime is going to be moved to 6, 7, -4, which is approximately here. And C prime is going to be moved to 2, -1. Okay, so we label our points. We connect them the best we can, and obviously, we might have a ruler or some tool with us so we can make it a little bit nicer. But we have A prime, B prime, C prime, and we can see that ultimately we've gone over 2 and down 5. Now, one thing that's cool is that because this is a rigid motion, what we know is that all we have to do is look at one particular point's pre-image and image, and that is actually all we need to determine how much everything has moved. So for example, if we look at A, where it started and where it ended, A to A prime, we can see that from A to A prime, we go over 2 and then down 1, 2, 3, 4, 5. Okay, and so because we know that we went to the right by 2 and down by 5 to get from A to A prime, we can reasonably conclude that that's what we're going to do for every single point. Because again, this is a rigid motion, so every single point is going to be moved the exact same. So again, to do it in verbally, we would say right by 2, down by 5, and technically we want to note that it is translated. Okay? So it's a verbal representation as well. Okay, so now we're going to describe. So it's one thing to translate, it's another thing entirely to describe. So what we have here is we have a shape, A, B, C, D. In this case, it appears to be a rectangle. And this rectangle has been translated to create the image A prime, B prime, C prime, D prime. And what we're going to want to do here is we're going to actually need to describe the transformation. So as I stated in the previous example, what we're going to be doing is let's start with any point. We're going to do A and its image, A prime. And we're going to ask ourselves, what do we need to do to get from A to A prime? You just choose one point. I chose A, it didn't an A prime. You could have chosen B and B prime, C and C prime, or D and D prime. It doesn't matter. You just have to choose a point. You've got to get the pre-image and the image. And again, I know that if I can just describe what's going on to get from A to A prime in this case, that is going to hold true because this is a rigid motion for the rest of the points. So I'm going to ask myself, well, what do I need to do here? So I need to go down 1, 2, 3, 4, and I need to go over 1, 2. And again, you can see if I had chosen C, 2, 3, 4, it would be the exact same thing. So let's start with vector notation. So vector notation, so I'll write a V for vector. Okay. So first of all, I know I'm going to the left. And so when you're going to the left, that means you're getting on the x-axis, you're getting more negative. So that's going to be meaning that I'm going to need to do subtracting. And to go left by 2, I'm going to need to be subtracting 2. Now, in addition, I'm also going down by 4. So I'm going to be using -4 to indicate going down by 4. How about coordinate notation? So with coordinate notation, you're always going to start with x comma y, and then we're going to draw the arrow to state that it's being transformed, and this is the rule. What's the formula, right, for how we're going to do it? So to make it go left, we're going to be subtracting 2 from the x coordinate, and to make it go down, we're going to be subtracting 4 from that y coordinate, okay? And so that is going to ensure that this shifts to the left by 2 and down by 4. You could always test that rule by using the exact coordinates. So A is currently at 1, 4, 1, 1, 2, 3, 4, while A prime is at 0, okay, or rather -1, 0. Sometimes, we got that tendency to mix up our x and our y coordinates. It happens to the best of us. All right, so that being said, if we think about this, let me just get my eraser. That's what I meant to do there. If we take 1 and we subtract 2, we get to -1. So you can imagine taking away the 2, right? Here's our example. Let's get you what I'm talking about. So if we had 1 comma 4, right? So we take 2 away from 1, that gets us to -1. We take 4 away from 4, that gets us to 0, right? Just like we have from A to A prime. And again, because this is a rigid motion, we can reasonably conclude that we're going to see the same exact thing happening no matter which point on that shape that we'd picked. Okay, again, that's one of the nice things about rigid motions. Okay, So now what we need to do is we're going to need to translate according to the vector. So here's what I'm going to ask you to do, folks. So now we've had a chance to look at translating according to vectors, translating according to rules, and writing rules to coordinate rules, that is, and then writing vectors and those coordinate rules to talk about transformations. What I'd like you to do is I'd like you to take a second and pause the video. Now when you pause the video, I'd like you to try to do these 3 translations. Translating JKLM according to vector 5, 2. Translating this shape, this trapezoid in the middle according to the vector -4, 0. And then translating this triangle according to the vector 1, -3. So please pause the video and try to do those translations. And then when you're ready, unpause and you can see what I got. All right, so let's take a look. So here we're going 5, 2. So when I do vectors, I like to try to draw the vector. So that gives me a sense I'm going right by 5 and up by 2. So let's take that with J. So K. Let's start with K. So we're at 4, -4, -2. So we're going to go 1, 2, 3, 4, 5, 1, 2. Okay, J. And you could even go the other way. Watch. 1, 2, 1, 2, 3, 4, 5. So one nice thing about translations is it doesn't matter whether you do the Y part first or the X part first, because they're independent of each other, right? You're going to manipulate what you're doing with the X, but the Y doesn't care what's happening with the X coordinate, right? You're doing a whole separate kind of thing there. So you can kind of do it in whatever order is easiest for you. Now what about L? L, 1, 2, 3, 4, 5, 1, 2. Good way to check your work here. Notice how K is going right 2 and down 3, and the new K is also going right 2 and down 3. So they stay the same amount over and down relative to each other. Finally, M, 1, 2, 3, 4, 5, 1, 2. And notice how M is down 2, the new M is down 2 and left 3 from J. And the new M is flat and even with L. So what I'm going to do is I'm just going to connect these to each other, since I've got the privilege of having my little tool here. And then if you did have original points, if you did have letters, it is a good habit to label J prime, M prime, L prime, K prime, because that's like declaring to me where's the new stuff and the old stuff going. All right, great. Now the second one is a very interesting challenge. So you're going to notice how there's 0 on the Y. So what that should indicate is actually no change is happening with respect to the Y coordinates. So it's only the X coordinates, and the X coordinates are all moving left. So I'm going to label this A, B, C, D, and again the X coordinates, it is all moving left by 4. So 1, 2, 3, 4. 1, 2, 3, and interestingly, B prime is moved to where A prime originally was. And that's okay. Sometimes that happens. It's just the nature of the transformation. 1, 2, 3, 4. And again, notice down 1 over 3, down 1 over 3, 1, 2, 3, 4. So again, you can see the rigidness of the transformation. And we think rigid, it's like those original proportions must be maintained. It's very rigid with respect to maintaining those relationships between the points. Okay, and so here's our new shape: A prime, B prime, C prime, D prime. Okay, all right, finally here we have 1, -3. So again, I'm going to label, and what you label them, if it's not specifically noted on the original shape, it doesn't really matter. If there are letters there already, like you see in the one on the left, you should try to honor the original lettering. And it is a good practice, in general, to have those there already. So just so you know. But in this case, they weren't there, so I'm going to call them A, B, C. So here I'm going to go over 1, down 3, over 1, down 3, over 1, down 3. And again, notice they maintain those very nice proportions, okay? So if I was to take the blue shape, that is, and I was to execute this transformation according to the vector, that blue triangle would lie directly on top of the red triangle. And again, that's going to play a very important role later on when we talk about the geometric definition of what it means for shapes to be congruent. So please make sure you understand what I did here with these three. Make sure you did get the same thing. And then when you're ready, please go ahead and we will move on to some more problems for you to try. All right, folks, so now I'm going to turn it over to you for another you try. So what we want to do here is we do want to try to translate according to the rule. So in the top shape, we have that xy goes to x plus 5, y minus 3. So it's literally telling you, again, how to manipulate the x and the y coordinates. And you can think about how that would correlate to a certain type of verbal rule, like translate left or right by something, up or down by something maybe. And then on the second one, we have xy goes to x minus 7, y plus 2. So again, please take a moment, pause the video, execute the translations according to these rules, and then when you're ready, unpause, and you can see what I got. All right, so our first rule here, this is indicating, I'm going to do a little bit of just kind of like using some symbols here. So this plus, now if you think about it, plussing on the x-axis, right, means getting more positive, right? If you add 5 to any number, even if it's a negative number, it's going to be more positive than when you started. So for example, A has the coordinates -5, 7. So when I add 5 to that -5, it's going to be more positive, right? Even though it's 0, 0 is still more positive, or it's closer to being positive than -5 is. So I'm going to go over 1, 2, 3, 4, 5. And subtracting 3 from y is going to generally result in going down. It's going to be more negative, right? Negative is down, positive is up. So 1, 2, 3, 4, 5, 1, 2, 3. That's going to be A prime. Now B is at 2, 7. So we add 5 to 2 and we get 7. We subtract 3 and we get 4. Good sign that A and B, the new A and the new B, are level with one another just as they originally were. Notice that they are off by 7. Here they are also off by 7. So they maintain that distance. All right, C, we're going to move over 5 and down 3. And again, notice 1, 2, 3, 4. They're off by 4. And you'll see the same thing happening for new D, D prime. So we're going to go ahead and connect. Okay. Now you don't need to know this fun fact. The vector form would be 5, -3. And again, you don't always need to use the vector form, but if you're in a situation where you're open to describing it however you want, you may want to consider using the vector form, because one of the advantages of it is, though it kind of sometimes is a little bit like, oh, what's going on there? It is pretty compact. It's got that nice compactness to it where you just, I'm not really concerned about the rules and the x and the y's. I just want to know, what do I add to x? What do I add to y? And if it's a negative, right, you know that that's going to be adding a negative or subtracting a positive. All right, going to the next one. This one means we're going to be going left because we're subtracting, and this one means we're going to be going up. So if we're at 2, we go over to 5, and then so we're going to end up at 6. Oh, I think we need to go over by 1, right? Double check this. So 1, 2, 3, 4, 5, 6, 7. There we go. And then up 2. C, we're going. Now, one cool thing is that because this is a rigid motion, see how C and D are 3 apart? So the new C and the new D are also going to be 3 apart. So again, we can use this idea of rigidity or rigid motions to really make it so I don't need to move all of those points, right? I can just establish one and then know, because it's a rigid motion, that C will be over by 3. A, 1, 2, 3, will be down by 3, new A, and then B will be right by 3. I can check my work. Ready? 1, 2, 3, 4, 5, 6, 7, 1, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2, right? So they all do check out, but again, because of that proportionality, all I really have to do is move one, and really everything falls into place. So consider how you can use that to really manipulate things in a lot easier of a way. All right, folks. So what we're going to be doing is we're going to be doing one more U-try. So in this U-try, we're going to be describing verbally, in vector notation and in coordinate notation, the translations you see here. So you need to be very careful in looking at the original and the prime. So in the upper left, we have red triangle ABC is the preimage. Blue triangle A prime, B prime, C prime is the image. Top right, we have triangle ABC in purple is the image. Triangle A prime, B prime, purple triangle ABC, is the pre-image. Blue triangle A prime, B prime, C prime is the image. And finally, in the bottom, at the bottom there in gray, kite EFGH is the pre-image, and kite E prime, F prime, G prime, H prime is the image. Okay, so again, the thing without the prime is the pre-image. The thing with the prime is the image. So please take a moment and describe using verbal, vector, and coordinate notation. We'll pause the video. We're going to try to do that, and then when you're ready, unpause, and you can see what I got. Alright, so we're going to start upper left, verbal. So all I'm going to do, again, I'm going to choose one point and I'm going to choose where it ends up, because since this is a rigid motion, I can reasonably conclude that every other point will follow the same rule. So verbal, V-E-R, verbal, because I guess vector also starts with V. Okay, so A, 1, 2, 3, 4, 5, 1, 2, 3. So translation, left by 5, up by 3. Okay, that's the verbal. So we're translating left by 1, 2, 3, 4, 5, up by 1, 2, 3. Okay, vector notation. So to go left by 5 means we're taking 5 away or adding -5 to the x, and going up by 3 means we're adding 3 to the y. And now we have coordinate notation. So remember, you always start with x comma y pointing to the rule. So again, you're taking 5 away from the x and you're adding 3 to the y. Okay? All right, top right, we're going to start with verbal. So it's a translation, and again, I'm going to choose, in this case, it doesn't matter, I'm going to choose C and C prime. So observe that C is at 3, 1, 2, 3, 4, 5. So C is at 3, 5. C prime is at 7, 1, 2, 3, 7, -4. So to get from 3 to 7, I'm going to have to go right by 4. And to get from 5 to -4, I'm going to have to go down by 9. Okay, and if you leave out the by, I think I can probably deal with that. All right, let's just check B to see if this is right. So B, if I translate right 4, 1, 2, 3, 4, and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. A, I can do the same thing. 2, and then 9. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I can see it works in all cases. So that's going to be a good sign. Okay, vector. What does that mean for a vector? So right by 4 means we're adding 4. Down by 9 means a -9 or adding a -9. And coordinate is x, y. Remember, you always start with this. And I'm adding 4 to the x. I'm subtracting 9 from the y. Okay? All right, lastly here we have the kite, so the verbal. So I'm going to choose H. Again, doesn't matter which one you choose. You just choose a point, a pre-image, and an image. So I'm going 1, 2, 3, left by 4, up by 3. All right, so translation, left by 4, up by 3. That's the verbal. The vector notation, okay, left by 4 means -4, up by 3, that is 3. And finally, the coordinate, okay, x, y, okay, so we're going to go to -4 from the x and +3 on that y value, okay? Okay, folks, so lots of stuff going on here, pretty challenging stuff, but just to summarize up what we're doing for this one right here, we're talking about translations, right? Or in other words, some people call them shifts, moving things left, right, up, down, or a combination of those. A big thing here is that they are rigid motions, meaning that every single point within and on the shape is being moved by the exact same amount. And we talked about ways to talk about it verbally, with a vector, and with a coordinate. All right, so this is some pretty challenging stuff. We'll continue to work at it, folks, but I hope you found this video to be helpful. Keep the questions coming. Never give up on yourself. And remember, you can do it. All right, thanks for watching. Feel free to like and subscribe so you can get access to all my videos as I put them up. Have a wonderful day, and don't forget to love me.